Thank you. So some 20-some years ago, I read actually a paper by a hacker called Demon9 that kind of introduced me to the whole post-exploitation and backdooring concept. And as I was developing the idea for PWND.sh, I kind of wanted to close the circle back and give a shout out to that great paper that got me there. So a little bit about myself. As has been pronounced, my name is Itzik Kotler. I'm in information security for about 15 years now, doing anything from developing to pen testing to red team. And recently I've co-founded a startup company called SafeBreach, which I'm acting as its CTO. Did a couple of conferences in the past. You're all welcome to visit my webpage, see a couple of slides, download the source code of the tools that I've released in the past. If you have any questions, always feel free to email me. Just to align everybody today about what is exactly the post-exploitation and what are the expectations that you can get from PWND.sh. So once you already breached into a system, once you already got access, then there is three major non-exclusive plays that you can then take. The first is you can further use that machine, that contextual information, IP, password, users, to basically further penetrate into the network and the other endpoints. You can maybe choose to get a more firmer foothold on that particular computer, deploying anything from a backdoor to a rootkit. Or if you hit the jackpot and that particular computer contains the information that you're looking to extract, then extrapolating the information will be the go-to item. When I thought about when I designed the PWND.sh framework, I basically took these three concepts in mind, so you can anticipate and see them being played out. So what is PWND.sh? PWND.sh is basically a post-exploitation framework written completely in bash, in shell scripting. And we'll double click into that later on to understand what is the advantage of using such technology. It's interactive, such as the nature of the bash itself. You can interact with PWND.sh, and it's also scripted. And again, we'll see a little bit more examples about that going further. One of the interesting concepts which I've targeted PWND.sh to be is to be deployed completely in memory. And we're going to have a little bit of slides discussing about the benefits of being in memory, but it's a very strong point considering forward when comparing the other frameworks out there. And one last but not least perk is that PWND.sh, being based on bash, plays very well with the Unix philosophy of pipeline. So the functions, the models of PWND.sh can be piped into, and their output can be piped to other tools. So basically, it's a win-win situation. So I'll give it a second there. Feel free to go grab your own copy. This is the release day. I'm going to drop the tool, so it's first time ever. Go clone the repository. Have fun. Let's move on. Okay, so there is a couple of very strange or interesting architectural design points that I've chosen going forward implementing PWND.sh, and we're going to touch about them in the next couple of slides. First, let's understand the idea of how does the project looks like. There is two major directories looking on the project itself. First is the bin directory, which contains a script called compile PWND.sh, which basically goes over the other directory, pond, and collects all the models, all the shell scripts, and basically compiles them into a single file. Now, the reason I did the compiled thing is because there is no actual compilation. It's more of normalization of the files, removing comments, and basically compile them or making one big file out of them. So it's good practice to keep in mind that whenever you want to make a change in PWND.sh, which will be persistent, then you definitely need to rerun the compile PWND._sh, and it will produce a new file as a result of the changes. So one of the maybe perhaps odd decision that I took going forward is I implemented the entire framework in shell scripting. So people can say, well, there's a lot of good scripting languages these days, anything from Python to Perl to Ruby, so why going with bash? Well, there is 5 good reasons here which I selected bash for. First is it's the same shell, but a different platform. And today, with my little capabilities, I've ran PWND.sh on anything from a Linux, a Mac, and even a Solaris. And you'll see a couple of examples from my laptop going further on. So we don't care about the platform. As long as it's the same shell, we get the same API. The second reasoning going forward is the architecture. I don't care what kind of CPU do you run. Again, same bash, same API, we get the consistency. So again, this is a cross-platform and cross-CPU. Bash has been the default shell on most systems due to backward compatibility with SH. Therefore, you can find it on anything from exotic embedded devices to modern operation systems. So you don't have to install it. Most likely, it's already there. And what makes Bash a little bit more interesting than compared to other shells, perhaps, is the ability to actually do socket programming. So this is not only limited into file system and process, this also can allow you, and as you will see in a second, to interact with other endpoints as well. And I think, last but not least, one of the major issues that I'd like to touch here is the idea of the fallback and the upgrade. Surely, we don't have to be single-minded going forward into what kind of post-exploitation framework we should work with during a red team engagement or whatnot. But by choosing the lowest common ground here, the shell scripting, we can always upgrade into a more sophisticated scripting language. So check out this code right here. The entire purpose of this code is simply to print a hello world. It begins by defining a variable called Python_bin, which points to what we assume is a location of the Python interpreter. It then goes ahead and checks if the file exists and at the same time whether it's executable. If it is, it will then invoke the Python interpreter with the command line C, which is a command line for taking input and run it as a program, and it will use Python to print a hello world. If there is no such file, or if the file is not executable, it will then fall back into Bash built-in echo. Either way, it will end up printing hello world. Now, if it would have been single-minded going with the Python from the get-go, and that compromised system doesn't have Python, then we'll get this very lovely error messaging saying nothing much can be done. This is why the idea of using the shell scripting, it can be a stepping stone to bring much more sophisticated tools on top of it, but if not, still give you some kind of capabilities on that machine itself. Another issue that I will click down into is whether you should be packing dependencies or not. So let's begin with why you shouldn't be using external dependencies going further with the PWND.sh. Well, it keeps the code consistent across different CPUs and platforms. As long as we're sticking to the Bash API, we can expect the same results on different subjects. It keeps the code smaller and more readable because we don't have to do all this what-if version path that we will do if we have a dependency to figure out whether it's the program that we expect with the version that we expect. However, on the flip side, the reason to go to dependency is you don't get to reinvent the wheel. You're using what's already in there and you're getting faster to the target. And there's also a philosophical question of what is it, the built-in Bash anyway? I mean, we are going to use tools like ls, like cat, like echo, which are binaries installed on the system. Bottom line, it's up to you. When I've developed PWND.sh, my philosophy in mind was use the least amount of dependencies philosophy, meaning that whenever I can to make something purely in Bash, I'll go ahead and do it. And if I can, then I'll try to find a very common dependency to tie it with. Now let's click down about the in-memory stuff and why is it very important. Going further with the red team idea, if you get to do a red team on an embedded device on non-standard computation appliance, then there's going to be some very weird conditions that you may run into. It could be the file system will be completely read-only, meaning you won't be able to write a file. It means that maybe the storage that computer has is very limited, and therefore you cannot write out your tools. By going in memory, you're basically eliminating these requirements and you're getting a functionality, you're enhancing your capabilities without paying the price of actually storing the information. Now going a little bit over to the red team, blue team kind of idea, another advantage of going in memory is that it disappears after a reboot. So once we're pulling the plug or stopping the process, everything goes away with it. So if you're doing some exercising between the red and the blue, then this could be a good way for you to understand whether in-memory changes of shells on this server, on that computer, are actually being detected and analyzed as expected. Either way, the design that I went with for PWND.sh is that it can be loaded in memory as well as on the disk for a fallback. And the fallback is mostly to ease up the development and the debugging of new features. So let's go over a really simple way on how you can just load right now PWND.sh into your bash. So as you can see, the first thing that we'll begin is by defining a variable called x, and then x will be equal to the content of PWND.sh fetched to us thanks to the curl. And then all we have to do is evaluate the content of the x variable, and we'll get the PWND.sh loaded. So let's just follow that instructions. Take some time. And here we are. As you can see, the indication that PWND.sh has been loaded, it changed the prompt to that color. Obviously, it's configurable, but that will be our indication that we already got into the framework. Okay, back to the presentation. Another way that we can do an in-memory loading if we don't have, for instance, the tool curl on the destination computer is that from your own personal computer, you can then go ahead and invoke the curl. You can then copy and paste that content into the clipboard. And on the destination computer, you can just do a paste directly into the variable, basically mimicking the same thing that we just did, but manually. And then again, evaluating that variable. That will pretty much get you to the same results without having the dependency of using curl on a destination computer. And for the on-disk loading method, for the fallback, as you can see, again, you can simply download the file, PWND.sh, and then use the source built-in command of bash to basically load that file. And it will give you pretty much the same result. There are no benefits, there are no any features that will be activated in one mode and not in the other. These are simply the different ways to get to the same conclusion. Okay, now that we got the PWND.sh loaded, let's do a little bit of a tour to see what the tool can provide us with. So as you can see, the tool is pretty much hooked up on top of bash. So right now, I can type commands, and these will be the commands. Oh, sorry about that. Here we go. So the tool is pretty much built on top of bash. It hooks up into the bash as being a bash script, obviously. And therefore, we can just type simple commands and basically interact with the tool. So as you can see, I've overwritten the built-in bash help command. You better pick it up. And you can then explore the different functionality that has been compiled into this instance. And we'll double click into each one of these models later on. But as you can see, this is the same tool. This is the same bash that you're used to. It's just been enhanced. So the first example will be a very simple port scanner implemented in our PWND.sh. To make this example, I'm going to spin up another server, another virtual machine on my computer, a Linux one, and that will give you kind of the idea between the variety of functions that can be across different CPUs and machines. So here we go, we have my Ubuntu set up, and I can then just go ahead and click and simply I'll log in to that machine so we can later on use it. But as you can see, I've just typed port scanner, and that's a part of the function exported by PWND.sh. And basically, I can just go ahead and scan ports on the different computers. I also developed a very simple yet effective help system. So as you can see, you can write help on each of the different models that I've supplied, and you can see examples of syntax going anywhere from multiple ports to range that can be supported. So again, let's go ahead and do a couple of more tests here. So as you can see, some of the ports are going to be open, some of them are going to be closed. Again, a very simple port scanner that you can use, completely written in shell script. Going back, the second example will be to extend the scope to do a little bit more of reconnaissance, not only to a single machine, but to the entire subnet. Here, we're actually going to leverage Bash existing shell scripting capabilities to get the same result. Okay, this is a little bit too much here for the examples. I'll just cut down the subnet into 3 hosts. And as you can see, I'm treating my PWND.sh model the same way that I will treat any executable, any binary. There is no difference. I'm going to scan myself on the daytime port. So as you can see, I've scanned, let's add the IP as well so it can show up. So as you can see, I've implemented a very simple script that basically loops on top of the port scanning capability to provide you a C-scanning, a C-class scanning kind of functionality. The example that I just gave using the Bash script looks a little bit unfriendly. I mean, this one-liner is cool and everything, but really going on a long term, not very maintainable. And as I mentioned before, PWND.sh can be scripted the same way that Bash itself can. So in the scanning the C class, the revenge of the script, this is an actual small script that I've developed to demonstrate how you can script PWND.sh. So it's very much like writing any shell script, except there is 2 caveats that you want need to know before going forward. One would be that, no, it's already there. One will be that instead of using $0 to get the actual file name, because we're not going to run that, running that script as is will replace our Bash instance, which will then take us out of PWND.sh. So we're going to source it instead. So when we're sourcing, we need to be careful about using the Bash source array to get the actual file name. Again, this is only good for the usage. And the second thing, as I said, we can't actually run the script. Running it will override our existing Bash. We can source it, and by sourcing it, we get an alternative way to actually scan, to actually run that script. So, as you can see here, PWND.sh can be interactive by nature, and it can also be scripted using simple shell scripts loaded in a particular method. Moving into a different realm, let's talk a little bit about backdooring. And as I said, this is one of the 3 main objectives that you can achieve once you're in the post-exploitation state of mind. So one would be, let's go ahead and deploy a root shell, a very common technique also mentioned in the article that I referenced in the beginning by Daemon9. You can use a root shell to hide an executable in the system that once invoked would immediately give you root credentials. So I'm going to use that on my Linux box. So SSHing into the Linux box, let's load PWND.sh on that machine as well. The internet is slow. Okay, so as you can see, in memory loading, we have now the Linux box also have running PWND.sh as well. So let's going to use the root shell analogy. Now, as you can see, I'm not a root at my computer, so I'm going to become root because eventually post-exploitation does mean that you have credentials or root credentials. So switching to another user, invoked another shell. As you can see, pond.sh is no longer in the game. So I'll have to load it once again. In the meantime, I will open another connection to the machine. So here I am, foobar, normal user, not a root, how shame. Back here, I am loading the pond.sh again into this root shell as well. As you can see, the familiar screen. I am going to install a root shell. As you can see, it created a file in temp and gave it the setuid bit. I'm going to take this file and I'm going to run it. And here it is. I am now the root. Again, a very simple root shell backdoor, but can be very effective. Okay, going forward with the capabilities, let's talk a little bit about remote. Sometimes we will have a machine, but we won't have access to it. We need to basically host it, open a different port so we can then connect to it. No problem. There is a bind shell functionality built into pond.sh. So let's go back into our favorite Linux machine, and we're going to ask pond.sh to start a bind shell, and from the comfort of my Mac, I'm going to connect to it, and what do you know? It's working. So as you can see, again, pretty simple, basic backdoor concepts, all implemented in bash, no dependencies. Going further into other examples, this is the second example. This will be the reverse shell, meaning that instead of connecting to the box will be connected to me. Very good when you want to jump over firewalls and proxies. In this case, we will do two things. First of all, we'll go ahead and on my Mac machine, I'm going to be listening on this port. And from my Linux machine, I'm then going to ask pond.sh to do a reverse shell. And hold up, why is that? Second. This is weird. Okay, let's try it with another port. Doesn't matter. So, invoking the reverse shell, and as you can see, back on my Mac, it connected into the netcat, and I have access to the machine. So up until now, we saw an example of both local backdoors, we saw an example of two remote backdoors, and some basic functionality for reconnaissance. Let's go to the other part, and this is for the search for the goodies. You would like to leverage the post-exploitation framework to basically help you understand whether the machine that you just compromised has the goodies that you're looking for. And I have, again, implemented a very simple model to do so, and basically looking for SSL keys. And we're going to go back into my Linux machine, and we're going to ask it to hunt for private SSL keys. And what do you know? There is a couple of them, and there is one right side my root directory. Now, this is a great functionality that can be expanded to obviously other goodies and other ideas as well. So let's see how we can then take this information from the Linux machine back to my Mac. So searching for goodies is one thing, but an exfiltration is another. And here we can see an example of how I'm actually going to use the entire Unix philosophy pipeline in action with the pond.sh. So I'm going to use cat to take the file content. There is no secret here. I'm going to encode it with base64. Why? Because I can. or because I want to evade some kind of privy eyes that looking into the traffic. And then I'm going to use a function called over the socket, which is basically kind of like a telnet that I've implemented inside PWND.sh, which allows you to pick either a TCP or a UDP connection that then will be open and tunneling the information on top of it. As I said before, one of the benefits of working with PWND.sh is that it plays well with existing tools, so you can leverage, you can do more with what you already have. So in order to accomplish that, I'm going to open back on my Mac the port 2021, and then I'm simply going to run this command, and what it will give me on the other side is the SSL key, the private SSL key encoded in base 64. So as you can see, we have looked over all the major models, which allows you to look for goodies, which allows you to do basic network functionalities, both inbound and outbound, and we also looked on the capabilities to drop a backdoor on the compromised machine. Now again, this is a version 1. These are very, very basic features, but the idea, and as I'll show it later on, can be very promising depending on the models that will be developed for it. So let's talk a little bit about how easy it is to develop for PWND.sh. And if you have some very basic kind of sysadmin Unix skills, then it should be fairly easy to do so. So the workflow consists out of going into the main directory, the PWND directory, then choosing a subdirectory which fits the purpose of your plugin, for instance, C2 for CNC. Then you create just a simple shell script, and again, we'll double click into that in a second, and that file will then be saved in that directory. Going back into the bin directory, removing the existing PWND.sh, compiling, and enjoy your new PWND.sh. As you can see, it's fairly simple, doesn't require much, only a basic shell scripting capabilities. Let's double click into what can be a very simple plugin that can be developed. So let's see, there is foobar.bash. There are two things that you need to keep in mind when you're developing plugins for PWND.sh. First is to avoid confusion, all the PWND.sh plugins are having the file extension of .bash. This would help you differentiate between just regular shell scripts and the actual models of that framework. The second thing is that you must call a function called pwnd_register command with the name of the model, the function of the model, and a description. This is kind of to make a good order about how you can register models and unregister them in runtime. So as you can see here, there's a very simple example of a function called foobar, just a model that prints hello world. And this is basically it. So if we're going to do a live demonstration of that, I'm going to go into the actual project here, and I'm going to pick a directory, again, C2, and this is where the existing models for the bind shell exist. And I'm going to create my own function, and just to avoid confusion, I'll do a copy paste here. So this is a very dummy plugin written into the framework. Now I have to do is I have to recompile PWND.sh. So I'll delete the existing. I will compile a new one. And just for the ease of use, I'll use the fallback file to upload it. So here we are. I'm going to do help. And as you can see, foobar now appears. And I'm going to call foobar. And it's going to do that. Again, very simple model, but the idea is that you can then extend it to kind of anywhere you want to go with. Networking, file system, process, it's all on the tip of your fingerprints. So just a quick recap of the plugin development rules. Files must always use the extension bash and not sh. Files always have to call the PWND register cmd in the bottom of the plugin code. And you must always wrap your code in a function because the PWND register command accepts two arguments. One is the function name and the other is the string of the actual description that appears when someone is going to do help on it. So where can we go for here? There's a couple of very interesting places that we can go. First is we can look on the Windows 10, which are just editor support for bash, basically extend the capability of PWND.sh to be cross-platform to Windows as well. So there's a huge potential here. There is a play that we can make PWND.sh cross-shell, meaning there might be an option to write a bootstrap code that will identify whether it's a bash, a zash, a cache, a fish, very funny names. However, identify if it's one of those, and then we'll pivot to a code reading in that shell script, meaning it's kind of going to be like a cross-shell and cross-platform. And of course, more plugins, more plugins to make things more interesting. Well, I believe that we are reached the end of our presentation. If you guys have any questions, feel free to shoot them. Yes?
Have you seen any restrictions on Bash's socket communications for like SE Linux or anything like that, or is it free for all for every user?
So as far as I understand it, it's a free-for-all. This is a feature, this is a great question. The feature that basically allows Bash to communicate with TCP IP is actually a compilation flag called enable net redirection. This actually means that Bash is creating a fake file system, which when internally addressed, Bash, the process, will then use the operation system TCP IP and socket capability. So there is nothing abnormal or changed about that. So I won't pick too much into ASCII Linux looking into it, but maybe, I don't know. Anyway, the safest play to be if you don't want your bash to have the capability is to never compile it with that flag. Yes?
So this socket programming flag, is it enabled on embedded operating systems like OpenWRT?
So I've not had the pleasure of checking it on OpenWRT, but I can tell you that on the systems that I did have the pleasure of checking, which was, let me pull up the list real quick here. It's part of the README, so let's see. So I had tested it mainly on 3 platforms: Mac, my Mac, Linux, the one that I just spin off, Ubuntu, and Oracle Solaris. So on those, I found that to be enabled outside of the box. I believe that this is a very modern and very kind of a common flag to use. But again, to answer, I don't know.
So it's sort of a virtual file system?
Yes.
That it creates that you can address these files within Bash?
Exactly. It allows you to kind of treat IPs and hosts as they were part of your net file system.
So that sounds a lot like Plan 9. So
Nothing is original any days.
that's how you do the port scans and everything?
Yes, exactly. That's how I implemented the port scan, how I implemented the reverse shell, the bind shells. These are exactly the techniques that I've used. Yes. Questions? Yes.
So if it's OpenWRT, it probably has BusyBox, so you probably won't have Bash on it.
Oh, that's true.
But do you have any fallback in the code so that if Bash sockets is not there, you can use netcat or something? Is anything else there? Please repeat the question.
Oh, of course. So the question was, if there is no bash, if there is no socket programming within the bash, can there be a fallback to netcat? So the question is absolutely yes. You can go and program these different edge conditions within the PWN models to go and say, if there is not such capabilities, then I would like you to use A, B, and C. And again, it clicks back into this example, which I call the fallback and the upgrade, which shows that if, for instance, you do have a Python, then you can go ahead and leverage Python capabilities. But if you don't for any reason, you can always fall back into bash. So yeah, most definitely you can query if there is a capability to have a net connection from the bash. If there isn't, you can just go ahead and do it with using netcat. Just to kind of show that example, it will either way print a hello world. So the same kind of thinking applied to other places, you can get alternatives in place. Any other questions? Well, thank you very much.